So we are looking at multiplexing and techniques in telephony as part of our lesson 3. Then, as I shared with you from words of Ken Wallis, so one of the outcome once you're done with the course is we should integrate VoIP to an existing data network. So there we need to do some labs. Then also you need to design a VoIP network for optimal voice quality. So that's where the QoS is to help us in voice quality. Then designing, then you need to know what are the design considerations for a VoIP network. Also, you should also know what are the components for a VoIP network. Then you need to examine the various types, call types in a VoIP network. I'm sure in our lesson 1, we looked at the different types of signaling that we have. So a call is just a signal. So, and I encouraged you that this is an area whereby you need a lot of reading. So examine, that's the verb. Examine the various call types in a VoIP network. Then we need to configure analog voice interface and dial peers. So where I requested you to download the microsip or to microsip is just to give us some, but these are digital one. So this is just for giving us a way of also working with the protocols. Then we need to perform call signaling of our digital voice ports. So here we'll consider the aspect of the ports and ports. We shall also consider the VLANs, the VLAN for data and the VLANs for voice. And because in this topic we'll be considering what you call the SIP trunking. SIP trunking is SIP. And in VLANs, that's what we talk about VLAN trunking. So these are the areas that we can progress on the VLANs. And I told you that we'll consider the VLANs next term, or I do VLAN presentation online and share. So that's an area we look at, and then we do some labs. The good thing with this, with the time that I have now, at least I can sit and do some simulations, or if not simulations, at least we can go to the labs. If not the labs, then we can work with the physical devices. And I'm sure next time I do a recommendation through the department so that we get these equipments in time. Not when we are doing the exams. At least we get some of these, like the analog phones, the digital phones, we have them. Then there's a protocol I would wish you to pay attention to, and it is in your exams. Maybe let me give you a leakage. Implement the H.323, the MGCP, and SIP protocol. They'll be in your exams, including the one on Friday. They are there. And they are there. So implement those protocols. We need to implement them. That's what with SIP. SIP has all those. The micro SIP has all those protocols. They are there. Then identify dial plan characteristics. So there we have something to read on. Then we need to configure advanced dial plans. Then we need to deploy H.323 gatekeepers. So you're asking, why are we talking about the gatekeepers? Yes, there are words about gatekeepers. In fact, as you shall be downloading, um, as you download some, I think it's in VOI, IP, MS, the word gatekeeper will feature in that site. So here, as you create the account in that platform, the word will feature. So those are technical terms in VoIP. They are different from the others. So approach it is a new area, and is an interesting area or the same. Then we need to implement a Cisco UBE router to provide protocol internet working. So that also now, the moment they introduce the idea of Cisco, then that gives us a room for doing labs in VoIP. Are we together? Yes, that what gives us a chance for doing that. So we can perform simulations based on that objective. So if you see me do some simulation on voice, kindly know because of that objective. You might not have the specific, because you know the issue of the school of the institution, maybe it's because of the supplier. Whatever you recommend, the supplier doesn't bring that. So the moment they bring that to the institution, that is what we work with. So the packet tracer is what we shall use. So the objectives are, we need to define the term multiplexing. We are going to look at what is this term called multiplexing. Multiplexing. Multi is from word multi, then multiplex. We shall see what that term means. It is a term for you need to know. Then identify 3 categories of multiplexing used in telephony. Then describe concept of multiplexing techniques. Then describe TDM. We shall see its full name and FDM multiplexing. And also we shall look at CDM, no, WDM, wavelength, WDM, see what it is. And then we shall also look at CDMA. So we see what is CDMA. Then under time, we also have a synchronous and synchronous multiplexing. So I can just maybe ask a question. What is multiplexing? What is multiplexing? What is multiplexing? More than one message. Okay, what you've said is actually correct. Another way of defining multiplexing. Yeah, it's just a techniques by which different analog and digital streams of transmission can be simultaneously processed over shared link, a shared link. You see, in the link, Um, I'm aware Mr. Bode is doing I think I think a research in wireless on links, and he will tell you that this link we are talking about, it is not only a physical link. He will tell you that we're also talking about a wireless link. Are we together? Are we together? So link is anything in between. Anything in between. Then, as one of the concepts is that multiplexing divides the high capacity medium into low capacity logical medium, which is then shared by different streams. So communication is possible over the air, that is the radio frequency, using a physical media, that is cable, and light optical fiber. Maybe you might ask, why are we talking about cable? And then we are talking about the optical fiber. Here is about the concept. Go together. The concept. So we can achieve multiplexing wirelessly. We can achieve multiplexing in the physical media. And the physical media here we are referring to STP, the coaxial cable. And then when you talk about the light optical fiber, I'm aware you have a unit called install something fiber. So the unique thing about light, and that's why you see we have talked about categorization, which are three, and among the categorization of multiplexing, we talked about um, um, WDM. WDM applies to fiber because light, light is an electromagnetic wave. And characteristic of an electromagnetic wave is that it has got speed, it has got wavelength, then it has got frequency. Are we together? Yes. So light is an electromagnetic wave. We'll consider now it's one of the properties called wavelength. All mediums are capable of multiplexing. While more than one sender tries to send over a single medium, a device called multiplexer or MUX divide the physical channels and allocate one to each. And allocate one. So you need a multiplexer and you need the other device, which we call the multiplexer or DMAX. So the DMAX receives data from a single medium, identifies each and sends to different receivers. So you can see a multiplexer is at from the source of the signal we have a multiplexer. Then after the link, and you have said it's either radio wave, a cable, and optical, whatever you have on the other end is a demultiplexer. So it does like now. It gives also a platform now for them to go to the designated or the different receivers. So you have a diagram. So that diagram is explaining or is just trying to explain to illustrate that we have different input signals. Then it goes through the max. The max does its work or its operation. Then all of them they goes through a physical the link. Now that is a single communication channel. So the word channel is what I said. Um, I'm sure he's working on something on channels, and the channel is something either to do with wire or radio. So in between, that is where we have um, some work done, and once the work is done in between, I cannot totally just say this is the work that is done. It all depends on what is being done on that link. But we are aware that we have the transmission and we have the reception. Are we together? In uh, any whether it's in wired or in wireless, we must have a transceiver, and we must have this transceiver aspect, whereby the one side is a transceiver, is a transmitter, the other one is a receiver. Then in between we have a link, the link. So that single channel, so that's where we achieve the area of the multiplexing, and they've said we can either achieve uh, the different categories. So then the other end, we have now each signal, now it goes back to its own channel, and and if you compare the input and the output, they're almost the same. Okay, so the path that it traced is the same path. The path that the input is the same path that the output. Okay, we together. That illustration helps us to understand the concept of multiplexing. So we can say multiplexing was originally developed in 1880s for telegraphy. Have you ever heard about the issue of the cat with its tail in US and the head in Europe? That is what telegraphy means. Telegraphy. So one person described that what is telephony or what is telephone, because they were wired, and they said it's like a cat with its tail in US and the head is in Europe. So in short, he just said you must go to Europe to hear the sound of the cat. Are we together? So in the same case that happens. So the tail here is referring to the kind of the media that you're using. Okay. Then the head, just simply that aspect of reception on the other end. And are we together? So we're just saying you need a transmitter, uh, something in between to connect the two. Then the other end you have a receiver. Then today multiplexing is widely used in telecommunication applications, including telephony. So that's why we are looking at multiplexing with specialty to specialty to telephony because of what we are looking at. So it's also used in internet communication, digital broadcasting, and wireless telephony. And for you people, you never know after this where you learned. Some of you might learn in digital broadcasting, so you should know that as you seek for attachment, one area you can consider is either in digital broadcasting, look for radio or TV stations. There you have a lot to learn. In fact, that is one area you can go, but you will just go as an engineer in that area or an intern in that area. The other area you can consider is the internet communications. You can consider in Kenya we have um, any organization that deals with the IP. Let's talk of Safaricom. Let's talk of Airtel. Let's talk of Jamii Telecom. Let's talk of which other? The Telecom Kenya. All those you can work. You can consider them, and don't focus on one. Apply as many as you can. Then the wireless telephone. So any organization that deals with what you have said is a good area for you. Any telecommunication company is a good place for you to start. Also because of the aspect of signal, we have also said also consider, for example, we call it the Kenya Ports Authority. Okay, they have a lot of instrumentation. Kenya Ports Authority. Then The Kenya Civil Aviation Authority, the KCAA, also is a good place for you. Or the KQ, Kenya Airways is a good place for you for seeking attachment, by the way. And also Kenya Wildlife. Kenya Wildlife is very good because they do a lot of they employ a lot of technology to do with sensors. Sensors in the case of monitoring of birds, monitoring of I'm sure we checked in wireless something to do with the RFID. Then we also talked about Wi-Fi. So these are good places for you to go and see what is being done. Are we together? And even for surveillance, the drone. You can also go to an area that deals with drones. So you're not limited. The good thing with a person who has done telecom, he can go to so many fields. So many, so many, so many. You can also go to Kenya Power. Kenya Power, they have a telecommunication unit. So you can go to such places. And if you go to such places, don't feel like you're not ready. You are ready. So right now is a module 3 trainee. You should know that you are ready for the work. Then if you have, so I just want to give you an example of multiplexing so that you understand what is happening. So if you have cable television service at your home, the television channels are all carried, and we are familiar with the issue of channels. Okay? Yes? They're all carried or multiplexed over a simple pair of wires. These include both the audio signals and the video signals. I'm sure those terms they should be very clear that when you're talking about voice session incision protocol deals with signals, audio and video. Are we together? Are we together? Yes. Because voice comes in two ways. I hope I'm communicating. Yes, it comes in two ways. The one is audio, the other one is in video. We're together. So the reason why we are talking about this protocol, there are some protocols which are specialized for audio, and there are some protocols which are specialized for video. Are we together? So I'm going to talk about kindly as you download the zip. You see, these protocols don't have a meaning, but they can be reinforced. If I come and talk about TCP, UDP, IP, okay, what is this they're talking about? HTTP, what are those things that you're talking about? But if you go to an email and you find them there, at least you start connecting, seeing the application right together. So as you download, the other objective is try to see some of these protocols inside, and I also make some notes on those protocols. Then you set up top cable tuner that then determines which channel is sent to your television by way of selecting the channel you want to watch. That's what play. You'll find there is KBC, there is NTV. Which is your favorite channel? No. Which is your favorite channel? Citizen. Station number 90. Yes. Cyrus. Which is your favorite channel? Citizen. Uh, which is your favorite? You don't say Citizen. You're talking about multiplexing. So you should talk about KBC. You should talk about KTN. At least we see the variety. All of them they are in one. Okay? They're one code box. They're in one. In fact, I can now talk about the codec or the code box. They're all in the same code box. But you can select whichever you want. So all of them are carried. So I hope that example gives you a better picture. Are we together? Yes. So whatever happens in there, that is the engineering that comes. Are we together? Yes, there's some engineering which you need to go sit, and you are taught by a professor in that area. So all of your channels are presented with the cable wires, but you select your selector is the set top tuner. So you can see why I said I first of all had to assemble these materials together so that at least anything that I'm explaining, at least you have a picture of what I'm saying. Then multiplexing, there are two. That's the other objective. Number two. So number one is, yes, Shadrach, yes. I just want us to name the categories of multiplexing that we have. Yes, is we call it the FDM. So next time you come across FDM, simply means frequency division multiplexing. The other one, yes, we have wavelength division multiplexing, WDM. Then we have the other one, time division. And this one for wavelength division multiplexing, you can also find of them talking of optical. Okay, optical wavelength division multiplexing. There they are very specific. If they talk about optical means optical light. So the wavelength there, we have said the wavelength applies to electromagnetic waves, and light is part of the electromagnetic waves. Then frequencies in analog, wavelength is in analog, then time division multiplexing is in digital. Are we together? Okay. Um, let me explain. Let me explain something about. Um, okay, we have talked about some wave, and we said this kind of a wave is a cosine wave. The other wave is a sine wave. By then, I'll give you some code in front, sine wave and sine wave. I'll just share with you a code. I'll just give you a code, then plot this. Do it together. And also, I also told you about there's another software. I told you to. The good thing is online. You can check on Octave. 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 It's an online platform. Octave or Simulink is the same. The same. They just mean the same, but its true name is MATLAB. The software part is the MATLAB, but if you go online, we call it the Octave. So also go to Octave, create your account, then it will help you to visualize what you're talking about. Go together. Right here. Yes. So if you look at this wave has its property in the sense that from this wave we can get amplitude. Okay? From this wave, from this point to this other point, we can get an element which is wavelength. Are we together? The length of the wave. Then also, we can also consider f is 1 over time. The period, we call it the period. Period is t. That is the time taken to make one complete cycle is what we call period. And you know frequency is 1 over time. Are we together? Are you getting my point? So this kind of a signal, they are analog in nature. And it's good to know that most of the signals that we have in nature, they are analog in nature. Are we together? Are we together? Signals are analog in nature. But the moment we introduce what you call PCM or quantization, or what you call sampling, what we sample is time. So we can sample, okay? We can sample and then quantize. Quantizing is just assigning them a value, the amplitude. You can say, for example, these are same wave, okay? Are you getting my point? These are wave. But the moment I introduce some samples in forms of these sticks, somebody said they are lollipops. So I introduce a lollipop here, I introduce a lollipop there. This is what you call sampling. But you can see the length of this is not the same as the length of the other. Are we together? Are we together? So the moment I introduce the idea of quantization, quantizing is assigning them a value. So this one can be A1, A2. Then I do sampling. It's like because of time, on time. So you can have NT1, NT2. N is because of the spacing, okay? Are we together? Then I can have NT1, NT2. So anytime I introduce that, now I move from analog, I do to what you call the digital. Are we together? So if you look at the time division multiplexing, we are talking of it as being digital, digital. Are we together? Are we together? Yes, there, that digital there, it means you have done sampling and done quantization. But for the analog and the other one, we have not done anything. It is just the way it is from nature. And we've said that most of the signals are analog in nature. Then the moment you start doing some processes in there, converting an analog to a digital, we does that using what you call a DAC, is a digital analog converter. That comes at the end. Okay? The output will be analog in nature. Are we together? And the output, the input will also be analog in nature. But to do an analog to digital, we have what is called a device called ADC. Are we together? But then to give the output in analog, we must have what we call a DAC, digital analog converter, or analog digital converter. These things you can study them in. I'm sure that you should have studied this thing in there's a unit you did called communication systems. Are we together? I haven't checked the OS. That's why I'm saying these things about the OS is a bit. They are a bit. I remember the other time somebody was asking me, did you you should have taught digital electronics, and I said we are not covering digital electronics. We are only covering analog electronics. Are we together? So if I say that you should cover them with that and do not cover, please just know that it's because of the way the OS is presented. Are we together? So my assumption is it should be covered. Just like there's an area we were looking, and I thought this thing that we should have covered about modulation, and we didn't cover about modulation. So I would say, please, this is an opportunity for you. Please, and I said in this unit must read a lot. So look at analog modulation and the frequency modulation. Kindly have a look at it. Are we together? Once you go to the industry, nobody will bother whether you know or you don't. They just say that you should know. And if you don't know, they might get offended. So we continue and say a two-wire analog, a local loop typically carries one call at a time. To make better use of wiring facilities, different multiplexing techniques have been implemented to enable two-wire or four-wire connections to carry multiple conversations at the same time. So you can either have a two-wire or four-wire. This question can be asked in an interview, so don't ignore. So we shall talk about now in our next slides on uh, time division, FDM, and WDM. So you have that time division multiplexing. You have a conversation 1, conversation 2, conversation 3, conversation 4, and then you have a conversation 20 to 30. So then once they are being sent in terms of slot. We call it the time slot. Time slot. So you can see a priority is given to 4. Okay, are we together? Then you have 3, then you have 2, then you have 1, then all the way to 20. Then again on the other end, as we exit, so they'll go in that. Okay, they'll be moving in terms of slots. So the order is 1, 2, 3, 4. Are we together? Then you break. Then you also take 4, 3, 2, 1. Don't forget what I was trying to illustrate concerning this. So we can allocate something here, and then on that time slot, are we together? So that's how they keep on allocating. So it's just the same. So the aspect of sampling is what we have 4, 3, then 4, 3, 1, 4, that way. Okay, slots. Are you together? Yes. So that's just a visualization of what time division multiplexing looks like. But anyway, if you do a simulation, these things they can make a lot of sense once you do a simulation. So, time division multiplexing is used extensively in telephone networks to carry multiple conversations concurrently across a 4-wire path. But any question? Okay. Time division involves simultaneous transmitting multiple separate voice signals over one communication media by quickly interleaving pieces of each signal after one after the other. So kindly, I wish you to check the meaning of the word interleaving, because it's not only just a term, it's a technical term and it's a technology. So information from each data channel is allocated bandwidth based on pre-assigned time slots, regardless of whether there is data to transmit. So that's about time division multiplexing. So time division is derived from sampling techniques in which message occupy all the channel bandwidth, but for short time intervals of time, the message share the the channel time. TDM provides a way to merge data from several sources into a single channel for communication over telephone lines, a microwave system, or a satellite system. TDM can be implemented in two ways. Remember the objective described as asynchronous and synchronous TDM. So we have those two. Then asynchronous TDM is normally known as statistical TDM. Okay. By the way, I don't want to introduce the aspect of statistics, but as you're aware, I told you that when I was in school just the other day, we did a unit called okay. There's a unit called All of Statistics. Not the All of Statistics, but the book called the All of Statistics. And I also came through a paper by Shannon called The Mathematica of Information Theory by Shannon. Shannon, he's the one who came up with explaining about transmission mathematically. Are we together? Statistics is about mathematics. And that's why you see somebody says, I've done mathematics and statistics. Are we together? So there's how you can explain the properties of a channel um, mathematically. I remember. The unit used to be called probability and statistics. Sincerely, you should also know that probability goes with statistics. So asynchronous TDM is known as statistical TDM. In synchronous TDM, a single channel is divided to time slot, and each transmitting device is assigned at least one of the slots for its transmission. So you can just go to the YouTube and check the difference between synchronous TDM and asynchronous TDM. Then you have that framework. Kindly also know how to draw the framework of synchronous TDM. So you can have frame 1, you have 1, 2, 3, 4. Those are different channels. Then as you send, you have frame 4, and you see the frame 4 has got all time slot for the conversation. Okay, so if you look at frame 4, it is divided into 4. Are we together? What we are doing here, what I illustrated in the sinusoidal kind of our just trying to explain about sampling and discretization. Then you have frame 2 and frame 1. So I don't need to, so we have number of inputs which are 4, number of time slot in each frame are 4. So that's an example of STDM. The multiplexer allocates the same time slot to each device at all times, whether a device has anything to transmit. So you see, the word synchrony is the same. Synchrony means same. Okay? Are we together? For example, when we have a learning online, like whatever we're doing, um, we are doing synchronous learning. Okay? So if we have some materials in the apps in the website of this session, we have them in online. So that stands from synchronous to asynchronous. Are we together? Because in asynchronous, you will discover that the time he will be learning is not the same time that Josh will be learning. Are you getting what I'm trying to say? Cyrus. So synchronous is the same time, same. Asynchronous is different. Are we together? So in terms of multiplexing, you're saying that the multiplexer allocate the same time slot to each device at all times. Are we together? Yes. And then the reverse is true. The reverse is true for asynchronous. So in asynchronous TDM, each time slot is not dedicated to the fixed device. So there is an issue of no dedication. The other one is dedicated at all times, but this one is not dedicated. So each time slot contains an index of the device to be sent to and a message. Thus, the time slot in a frame is not necessarily to be equal to the number of input devices. More than one slot in a frame can be allocated for an input device. Asynchronous TDM allows maximizing the link. Now, a question. Which is the best between synchronous TDM and asynchronous? Which is best? Which best? Okay, now I have told you about learning. Which is the best? Which type of learning do you think it has the best advantage? You can compare the two. Is it the synchronous, what you're doing now, or is the asynchronous, whereby you do it at your own time? Both of them, don't just weigh down on, don't overlook, okay? Are we together? Don't overlook. You say that synchronous or asynchronous, coming to class or not coming to class. The video is uploaded there. So do what we say this. Can you just compare the two? Okay, and then try to get the advantages and disadvantages. So both are okay, but you can see in terms of channel, one remains dedicated that this time is for this. Okay, so if you introduce another person, he must be given a certain link. Are we together? So you notice that in asynchronous, so the moment the session is done, that one is done. Another person can use it. So that's how we maximize the link. The link can serve other conversation. But for synchronous, whether you are communicating or not communicating, are we together? And that's where the word code division, multiple access comes in. For example, like your phone. After we communicate with you, Josh, Safaricom has given us that. After communicate with you, the moment the communication is done, that channel can be given to Cyrus talking to Shadrach. That's asynchronous. But if the same channel, we end conversation with Josh, and no, that channel is not given to somebody else, it is fixed for us. So you can imagine how many channels can you create for all those conversations. Are we together? So you can see that the conversation is, I will leave the question to you to see which one works best. But at least you've gotten what we mean by asynchronous. It also allows a number of lower speed input lines to be multiplexed. A single high speed line is shown in the figure. So we have a figure on so you have 4 inputs, then you have the asynchronous, the number of inputs, number of slots in each frame. There are 3. The other one, if you looked at it, there were 4. And also, if you looked at them, they looked a bit big. They looked a bigger. They looked a bit big, okay. But these ones, they are smaller. So it's also good you understand. The number of inputs are 4, but the number of slots in each frame is 3. Just to, in case one we assign it to another person. Are we together? Nobody has that dedicated time. Are we together? Yes. So advantages of TDM: it uses a single link. It does not require precise carrier matching at both ends of the link. The use of capacity is high. Each to expand the number of users on a system at a low cost. There is no need to include identification of the traffic stream on each packet. Disadvantages: the sensitivity to other user problem is high. Initial cost is high. The noise problem for analog communication has greater effects. So how much time is remaining? Okay, at least I have time to finish up. So now let's look at frequency division multiplexing. Frequency division. So the other one we are considering time, but the other one we are considering frequency. Now, and by the way, most of your devices they work in frequency. True or not true? True. They work in frequency. And you might ask yourself why. There's a reason. There's a reason why we work with frequency, but those reasons I can only prove to you mathematically. So caller 1, caller 2, caller 3, caller 4, and caller 5 is just an illustration of how it works. Frequency. Frequency. What is FDM? FDM is derived from AM techniques in which the signal occupies the same physical line, but in different frequency bands. Each signal occupies its own specific band of frequency all the time, i.e., the message shares the channel bandwidth. Okay, underline the word bandwidth. Underline the word bandwidth, and also try to understand that the bandwidth is like a pipe. It's like a pipe. You can have a pipe with a cross section with varying cross section. Are we together? There are some, for example, if you need to supply water to from Embu to Rueka. What is the size of the pipe? Very big, okay? But as you you try to, which term plumbing do they use? If you want now to tap or you extend that water to for household consumption to small residential areas, you need a small pipe. Are we together? It's the same case. Now imagine you are using the same pipe to supply water um, to your cubicle. Now, does it make sense? The first thing is the cost. The cost will be very high. So in short, I'm just using the size of the pipe just to understand what we need about bandwidth. Not everybody needs the same bandwidth. Are we together? Yes, and bandwidth, anytime you talk about bandwidth, don't forget that bandwidth is given by 2F. What is F? F is the sampling frequency. So bandwidth equal or multiplied by 2Fs. And for your case, there's what you call the baseband. And baseband is something like that. Filtering. There's something about filtering. So you can have F1, and you can have, okay, between these two, which one has almost has the same property as this? Is it the sinusoidal or the cosine? Is the cosine. Okay? So in form of information, we can say this one has what we call even, and then the other one has what we call the odd. Because if this is positive, the other one is negative. But this one, you can also have, yes, both are negative because this one is in the positive, then the other one is in the negative. Okay, let me go and try to, I don't give, I came to realize there's a difference between misinformation and disinformation, and which other term? You can either be misinformed, you can either be disinformed. There are those terms. There are those terms. So I don't want to give you some information either to disinform or misinform. But let me try to check. But I can consider the following: what you call symmetric. Symmetric. According to symmetry, this one is more cosine is more symmetric than the sine. Okay, are we together? It's more symmetric. It's more symmetric. So we can also consider. And remember, this is information. It is information. So we can say that each signal occupies its own specific band of frequency all the time. The message share the channel bandwidth. Then what is FDM? It involves carrying multiple voice signals by allocating an individual frequency range to each code. Now, uh, can you converse? Let's try to converse here. Let's try to converse. We start with visuals. We have our ear. Are we together? How does what you can hear me? How can you hear me? There's no medium. Or there's a media, yes, there's a media called the air. Okay? What is happening to the air? Are you aware there's a lot of things that are happening here? I'm speaking at a certain frequency. Okay? I vibrate the air at that frequency. That wave comes to your ear acts like a filter. What you're talking about here, it acts like a filter. Okay? It picks that frequency. Then once it goes on the back of the eardrum, it vibrates. Now, that vibration is all analog. Are you together? Remember sound. Sound moves in what we call rear function and compression. It's a longitudinal kind. A transverse is, but this one is a longitudinal, comprises of compression rear functions, where compression are high pressure zones, then rear functions are low pressure zones. Okay? The same comes to your ear, then it goes to your ear, then it is sent in form of electrical signals to the brain. So the brain interprets that, and then after interprets, now you make a decision. I want to respond. So as you respond, something here works. The voice. Some sound are produced. Then the voice acts like a loudspeaker. We have a loudspeaker. All of us, we have loudspeakers. And we have amplifiers. This is the amplifier. Okay? And the nose. So the reason why God has given you the tongue, the teeth, All those things, they're just to help you to in speech. Not only for eating and just for speech. Then the moment you talk, I'm also to, so you can see there's a lot that happens. So in short, it's good to note the following. When you're considering the voice signal, the voice signal is allocated to an individual frequency range. So for us to hear, we human beings, we hear something at this range, 20 hertz to 20 kilohertz. We hear that. Are we together? So human beings, we hear in the range of 20 hertz to 20 kilohertz. But for telephony, they work under 8 kilohertz, the minimum, to 40. So this tells us something. If anything speaks beyond this, lower than this, or higher than that, we cannot hear. And that tells us why dogs can hear. There's some noise you can make, and you see your dog is very much irritated. You cannot hear, but because you cannot hear doesn't mean that that sound is not there. Are we together? Yes. So anything below than this you cannot hear. And for telephone, because for us we are in this range, so the telephone are designed the frequency of 8 kilohertz to 40 kilohertz. Are we together? Yes. So frequency division is a technique used to divide the bandwidth available in a physical medium into a number of smaller independent logical channels, with each channel having a smaller bandwidth. FDM is used in cable or digital subscriber line. Kindly check at DSL and also check at ADSL. Kindly, I've said check at DSL and also you check at ADSL, asynchronous digital subscriber line. Check what are that. Connections allowing the simultaneous use of multiple channels over the same. So I've said ADSL and DSL. Notice that even though there are gaps, guard bands between the channels, there is some overlap between adjacent channels because the filters do not have sharp edge. This overlap means that a strong spike at the edge of one channel will be felt in the adjacent one as non-thermal noise. Frequency division works best in low-speed devices. Remember what I said? Are we together? Are we together? So if it works very best at low speed, don't forget that the frequency is given by speed over wavelength. Are we together? Yes. So if the speed is smaller, there's something that we should know. Speed is influenced by wavelength and frequency. I will try to rush because of our time. So you have that diagram, and also kindly consider the guard band between the various channels. We have just a guard band. Try to see what we simply means by guard band, but let's pay attention to the frequency. So you can see there is that frequency. So the ones that looks like a house. Then in between you have the guard band. What do you have the guard band? Okay, something for that. Okay, check why we have that. So advantages. Here user can be added to the system by simply adding another pair of transmitter, modulator, and receiver demodulators. FDM system supports full duplex information flow, which is required by most of the application. Noise problem for analog communication has lesser effects. Disadvantages in FDM, the initial cost is high. Then in FDM system, a problem for one user can sometimes affect others. In FDM system, each user can require a precise carrier frequency. Applications of FDM is used for FM and AM radio modulations. Then FDM is used in television broadcasting. Then the first generation cellular telephone uses FDM. And also good to know that for broadcasting, we talk of 88 to 108 megahertz. I'm sure that one you know in one of the units you have covered. Comparison of FDM and TDM. FDM message occupies narrow bandwidth all the time. TDM message occupies wide bandwidth for short intervals of time. Are we together? That also can tell you why we are focusing more on FDM than TDM. TDM. Are we together? Are we together? So let's look at the last one. Wave length division multiplexing. It refers to application of DM to optical fiber. The input and output of such multiplexing are wavelength of light noted by the Greek letter lambda and informally called colors. When white light passes through a prism, colors of the spectrum are spread out. If a set of colored light beams are each directed into a prism of the correct angle, the prism will combine the beams to form a single beam of white light. Okay. Um, okay. In our before we proceed with before we introduce the next thing that we need to talk about, I'll give more light on WDM because right now we're in the era of optical fibers that are proved of help to society. So we cannot ignore such kind of technology that is there. Okay, we'll give it more attention, and I'll explain more about spectra, what you call the spectra, and what you call the white light, and the spreading out. Okay, as I'll explain what it simply means by that. And also the idea of the prisms. So, but the information that we have is that is this what we have on that slide. So we have that prism. We'll focus on the same. So I would wish you to know that what we've said about multiplexing, we are simply talking about convergency. We converge at that point at the input, then at the output we also diverge. Okay. Yes. And also know the categorization. I've said we have the FDM, the TDM, and WDM. So I wanted to assign you some work, and also that work is for you. You need to describe the three categories of multiplexing and explain the terms multiplexing, AM modulation, and FM modulation, chord division, multiple access. And remember my work, and then describe the application of TDM, FDM, and WDM. Then compare FDM, TDM, and WDM. Then also differentiate asynchronous, TDM, and synchronous. So those are your review questions. So I've given you some references, you can check them. So that brings us to the end of our multiplexing.